Good morning, everyone. Sorry, I'm having a 12-hour difference, and so I'm making this video to introduce my research. My name is Eric Du. I'm a professor in the Department of Civil Engineering. I'm also affiliated with Mechanical and Aerospace Engineering and Industrial and System Engineering. At UF, I direct Informatics, Cobots, and Intelligent Construction Lab. We do three tracks of research. First is motor training. The second track is embodied robotics. And just recently, we started this track of research in the area of AI cognition and AI alignment. As for motor training, we started testing the idea of using virtual reality and later mixed reality to train first responders to use exoskeletons in their tasks. So the idea was creating this immersive environment and use motion capture techniques and eye tracking techniques to track the performance and functions of the users. And we also capture a lot of high quality data from the experienced users. And we visualize the data with simulated avatar, and we test the different view perspectives such as a first person view, third person view, plus the use of whole body haptic feedback, and to see how effectively it is to train first responders to use passive exoskeleton and active exoskeleton. So we were founded by several agencies such as NSF Convergence Accelerator, and we have been working with more than 200 first responders, and we have a lot of data to understand the motor learning process and the retention of the motor learning in terms of using exoskeleton. And we were also testing the use of real-time musculoskeletal modeling, and we tested how this real-time immediate feedback with info panel, as you can see here, and some of the visualization can help expedite the training process. And later we also tested the multi-user functions, so we could engage trainers and trainings from a distance in this real-time interaction. And in terms of robotics, so we originally started the use of teleoperation since 2019. As you can see here, my son was having fun with this teleoperating robot hand, and we also created this bilateral control method that allows us to control a remote robot while you can also feel the payload from the remote robotic effector. And we collect that high quality data and send it to imitation learning process and also inverse reinforcement learning process to train robot how to perform dexterous tasks such as inserting a PEP into another PEP. And just recently, since 2023, we also started building our own foundation model of using tactile sensor. As you can see here, we equipped the robot hand with optics tactile sensor. The hand could feel the deformation at the contact point, and then we send it to a transformer architecture. So and to train the robot hand to maneuver a soft cable through this 90-degree elbow. Just recently, we also started testing more advanced AI systems in controlling complex systems such as a drone flying through a city with a lot of environmental impacts such as wind and 5G coverage. So the idea was to train AI model to control this drone flying through this city block, while the drone could feel what's going on in the environment and also understand the priority of the task and setting out the goal and finding out the path by itself. And then we found there's a big gap between the AI decision making and the human users. So we created some scenarios that the drone and the human user must make collaborative decisions and very complex decisions, such as what is more important in terms of finishing the task. Should I avoid wind first? Should I try to shorten the flying time as much as possible, or should I cover a bigger area as much as possible, etc. So we use explainable AI techniques to visualize how the AI is perceiving the environment, and how AI is making the decision at a critical time point, such as inferring the status of the environment based on incomplete information, and then deciding what is important, and then also change the flying strategy for the drone. And meanwhile, we visualize everything through virtual reality and haptic feedback suit to simulate event, for example, and to the human observer. And the human could, if they want, interrupt the decision-making process of AI. So we are still in the early phase of this track of research. The idea is to study AI as a more complex cognitive entity, and see how we can narrow the gap between human decision makers and AI decision makers. So our lab is funded currently by National Science Foundation, NASA. We have been funded by NASA, Air Force, and the NIST. And I look forward to working with you guys. Thank you.